As a reminder, when simplifying radicals, you want to simplify the expression. It seems you guys are moving towards that. So multiply and divide things first, and then worry about simplifying the radical underneath. And remember that you are trying to find factors of the radicand, which is this, factors of this, that multiply by themselves n times. So, here's 19 and 20. 19, the index is 2. So you're really just looking to divide the exponents by the 2. So 4 divided by 2 is where this x squared came from. And y to the 6 divided by 2 is where y to the third came from. It's that easy with variables. So this one's a little bit different. This is number 20. You have the square root of 78x squared y to the third over the square root of 6y. So as I said, you really want to simplify top and bottom first, right? You want to look to see, do 6 and 78 simplify? They do. 6 goes into 78 13 times. And y over the y cubed over the y simplifies as well. So your whole denominator cancels out, which is ideal because then you don't have to rationalize the denominator and simplify from there. So now we just want to look at our simplified radical, the square root of 13x squared y. 13, the only factors of 13 are 13 and 1, so that's why it stays under the radical. But again, we have a radical, it's just a square root, which means we're looking for sets of 2. Well, x times x gives me x squared, and y times y gives me y squared. So that's why the x and y both get out. Okay, here we have 21. So all I did for 21, I have the square root of 12x y cubed times the square root of 24x cubed y squared. So I just took the 12 times the 24, that's where the 288 came from. The x times the x cubed, that's where x to the fourth came from. And y to the fifth times y squared, and that's where y to the fifth came from. So then I worried about doing the square root of that. So as a reminder, you can set off to the side your numbers under the radical and just do a factor tree. So 2 times 144 will give me that 288, and then 12 times 12 will give me the 144. So I know to stop there. I can clearly see, okay, it's a square root, and I've got 12 times 12, so I can just pull the 12 out. The 2 doesn't have a partner, it goes underneath. If you just sort of get into the mode of simplifying the radical and don't see that, that's okay. If you keep going, it's going to end up being 3 times 4, 3 times 4, and if you keep going even after that, that's okay. Know that you're looking for pairs then. So you have a pair of 3s. So that means they'll get out. You have another pair of 2s. So for every single pair that gets out, you take the square root of 2 times 2 and it's a 2 on the outside. This guy is stuck. He does not have any partners, so he is stuck under the square root. So then again, with the exponents on the variables, we have x to the fourth. It's the square root of x to the fourth. It's just x squared on the outside, because the square x squared times x squared equals x to the fourth. And then y to the fifth. Remember, y to the fifth is like having 5 y's. So if you forget the division rule, you're just looking for pairs again. So you have y squared on the outside because you have 2 pairs, and the square root of each of these pairs is 1y. This guy does not have a partner, so he is stuck underneath. So you need to go ahead and simplify that. So 3 times 2 times 2 is 12. x squared, y squared, 2y. Looking at 22, we have a subtraction problem. So subtraction and addition, not quite as straightforward. You need to simplify first because you can only add and subtract like radicals. And as you can see, these are not like radicals. So the thing that's a little bit different about this one, it's the fourth root. So that means we're looking for sets of 4. So we just did a factor tree on the 324. We got it down. My prime numbers are 2, 2, and this set of 3s. So that's why the 3s get out, because it's a fourth root and there's 4 of them. The 2s don't get out because the 2s, there's not enough to get out of a fourth root. So that's where this 4 comes from. Then doing the same over here, we do a factor tree on 2500. We get 5, 5, 5, 5. We have 4 5s, so the fourth root of 5 to the fourth is just a 5. And then we have 2 times 2 again. Again, not enough 2's to get out of a fourth root, so that's why they're underneath as a 4. So now we have like radicals. We have the fourth root of 4 and the fourth root of 4. So this is just like adding 3x minus 5x. We would get a negative 2x. Well, it works the same with radicals. You're really just adding and subtracting the number out front, which is how we got a negative 2 fourth root of 4.